Hey everybody, I'm Corey. Thanks for tuning in. I go by Corey JA on the internet. You can find my blog and site here at CoreyJA.com. You can find me on GitHub, YouTube, and Twitch also as Corey JA. And today we're going to be doing some Advent of Code. It is December 10th, so we are on day 10. Advent of Code is these nice little programming puzzles that come out every day from the 1st through the 25th of December. And we're going to dive into day 10 now. So day 10, pipe maze. You use the hang glider to ride the hot air from Desert Island all the way up the floating metal island, all the way up to the floating metal island. This island is surprisingly cold, and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you'd ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see, your puzzle input. The pipes are arranged in a two-dimensional grid of tiles. The vertical pipe is a vertical pipe connecting north and south. Dash is a horizontal pipe connecting east and west. And then we have other 90-degree bends, like an L is a 90-degree bend northeast, J is northwest, 7 is southwest, and F is southeast. And then period is ground, so no pipe. And S is the starting position of the animal. There is a pipe on this tile, so your sketch doesn't show, what shape the pipe is. Okay. For example, here is a square loop of pipe. So this is just showing pipe that connects all the way in a square. If the animal had entered this loop in the northwest corner, the sketch would instead look something like this. Yep, so we don't know we know this is the starting point, but we don't know its shape anymore because it's the starting point. But we can see there's two things leading out of it. In the above diagram, the S tile is still a 90-degree F bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. So we have our square here, but there's also pipes just kind of all over the place around it. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. Those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed is to connect back to those two pipes. Here's a sketch that contains a slightly more complex main loop. So in this main loop, you start here, it connects, there's a J, this F, 7, yeah, so it's just a very long one. There's only one loop, and it's the whole main loop, and everything's interconnected. Here is the same example sketch with the extra non-main loop pipe tiles also shown. Man, I don't like, okay, maybe if I just keep this out so it doesn't keep moving up on me, but I'll make it smaller. Perfect. Okay. So our main loop, we go down, up, this way, then this way, this way, this way, this way, this way, this way, this way. There we go. And it connects. But there's other pipes like this pipe, and there's just lots of other pipes that are just thrown around. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting point. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. In the first example, with the square loop, that's the opposite corner, you can count the distance each tile from the loop is from the starting point like this. And then you find the one with the maximum, which is 4. Here's the more complex loop again. You draw the distances away, and you get 8. Find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the farthest point from the starting position? Okay. So I don't think this is going to be too bad. We'll start with parsing in a minute. I think parsing and stuff might be the hardest, but I think once we get from an S, we know there's going to be two directions that lead to it. So we can just like find those two directions and then from there just follow the pipes until they loop. And we actually don't even need to do both directions. We can just pick a direction and then follow the pipes until we get back to that. That'll give us a list. And then at a minimum from there, no, I think that's all we need. From the list, we can figure out what the midpoint is, and the midpoint is how far away we need to go. So yeah, we just are going to need to parse into something that can help us figure out the directions. So there's definitely a bit of parsing going on here. So let's get started. Let's copy some sample inputs. So here is our, okay, so where's our simple one? So this is the simple sample input. Oh, we don't even have a cargo binary yet. So cargo new binary. We're on day 10 now. Look at that. And this one is called pipe maze. So pipe maze. And then we're going to name it pipe maze. We'll edit our top level cargo for our workspace for pipe maze. Awesome. And then we can cd into it in cargo run and should just get our hello world. Perfect. We already have this on our clipboard, so let's just do simple sample.input. Drop in that. So let's then do let simple input, simple sample input. Oh, so close, Copilot. And then let simple sample part 1 answer. Yeah, let's debug that out then. Debug. And let's make the part 1 function part 1. Takes in an input and returns a usize. That works, but let's make it a to-do instead of 0. And let's think about the parsing here. Okay, so I think we're just going to parse into a grid, so like a vec of vec, so that we have the 2D grid thing. And then each of these is just going to be like an enum probably called cell. And we're going to name each of these and parse into something like that like knows which directions they leave from and stuff like that. Yeah, I think I like that. So like we're going to have a struct called maze, and it's going to have a grid, and they're not going to be of characters though. We're going to call them cells, and we're going to have a struct cell. Oh, I actually was going to make it an enum. Yeah, let's make it an enum so we can do matching and stuff. This is kind of nice though, where you have a cell that just says which way there's doors. Because then I can just like construct the one I need and just check the directions. No, let's go to the enum. I think I like that better. Struct enum cell. And there's empty. There's no, yeah, so there's empty. And then there's the different pipes. Oh man, maybe I do actually like the way they had that. Maybe I do actually like that pipe. And then, yeah, which way do I like it? Now do I want a vec of directions for a pipe? So a pipe has connections, which is like a vec of direction. We could do that. That's not bad. Enum direction, up, down, left, right. So this is a pipe of a pipe. So it's either empty or a pipe. Yeah, that makes sense. And then the pipes know which directions they can go. Yeah, that works for me. I like that. Should cells know about their position, or do pipes want to know about their position? I guess no, because I haven't, it doesn't seem like that's how I've structured this. We'll just take that in when we ask a pipe questions, and that'll be fine because we'll know the position from where we are in the grid. Okay. So let's first just add debug derived to all of these. because we're going to want it. I think and a few of these want something else. So this is going to be copy clone because this enum, I just want to be able to copy it nice and easy. This has a vec though, so it's not going to be copy, but we'll make everything clone. There's no reason for anything not to be clone. We're not going for max efficiency in this. And okay, so let's start off with, yeah, I like starting off the top. Impl, maze. We're gonna write some parsing functions. Function parse takes in an input string and returns a self. Okay, so then let grid input lines parse characters. Yeah, that's actually really close there, Copilot. You had the idea completely right, but the imple's a little different. So if you get a period, it's empty. If you get a vertical pipe, there's a connection up and down. If you get a horizontal pipe, there's a connection left and right. Perfect. We don't have that type of connection. So we have different ones. So let's just delete that. And we have a one that's like we have the 7, which has a left and a down. Left and down. We have F, which is right and down. What are the other two characters? I'm forgetting. J and L, which is up and right. And we have a J, which is left and up. Perfect. 1, 2, 3, 4, 5, 6, and then 7 with that one. 1, 2, 3, 4, 5, 6, 7. Oh, and our starting position. Yeah. Yeah, just starting. Just start. We just need to delineate it. I think nothing exciting. Replace it. Start. Okay. So that actually, can I like, this is perfect, but I actually want to break this up a little bit more because I want to have a impl on cell. That's function parse from an input, which is actually just going to be a character because that's fine. We go to self. We just copy this whole match. And we're matching on input. Perfect. And then so this can just be com cell parse. Parse. Nice. That looks much cleaner now. So we can get our cell and our maze. So let's wire that in and at least debug it out. Let maze equals maze parse. Debug maze. Yes, with a to do. So it compiles. Awesome. We can do run. And it should just fail at not yet implemented, but we get our map. So we have some empties, left and up, left and right, right and up, up, down. Looks like this is right to me. Hard to say exactly, but I think so. Okay, so let's see where we want to start here. So we need to be able to find our starting position. So like that is pretty easy, but let's write that code. So impl maze function start. Yep. And actually, let's actually make a position that is this because I like having a struct for that. So struct position. Yep. So this is going to return a position. Position XY. Perfect. Let's see if Copilot did that correctly. For grid iter enumerate, yes, we're going to loop through all of the grid items and then each row of that. we get the y and x from the enumerate. Yep, we shove them in. Nice and easy. Panic, no start found. Yeah, we'll panic if there's none. I like that. Copilot knew what we wanted there. So let's just see if that works. Start. Oh, and of course, position does not implement debug yet. Drive debug and clone. That works for me. And actually, let's just make it copy. I don't want to deal with cloning these manually ever. And we get, yeah, starting position of 1, 1. Perfect. Okay. So let's see. I want something that can decide, that can find at least a connection from the starting point, but I guess I want both of the connections from the starting from a position. So function connections for self and a position is a vec of positions. Perfect. So let's sell. Yeah, I don't know why it did yx, but that is what it did because it's doing the first one as the y's and then the x's. Oh, because I actually am reading it from no, that does make sense because of how we read in the coordinates, I think. Actually, that's kind of important, right? Does it need to be starting from the, because the left and right stuff is gonna get mixed up. Well, I just have to make sure I get my mapping of positions and directions right, which I haven't done yet. So I guess that is about to happen. Nice. Okay, so if it's empty, this is just a, I guess this can panic probably, right? It could do empty, but like empty cell has no connections is better. Or should it just return an empty vector? I don't know. It doesn't really matter. Basically, I think I should never call this, so let's keep it with panicking. If it's the pipe, then this should be relatively easy. I can do pipe dot nab connection positions or something. Connection positions. Passing it. Yep, exactly. Can generate this method on pipe. Yep. So then what we're going to want to do is we match on self. Oops, we have Rust Analyzer, fill in. Oh, yeah, I forgot. This isn't a thing to match on. We want to do self.connections, something like this. Yeah. We want to iter and map over all of the connections. And if it's up, we're going to subtract a y. If it's down, we add a y. If it's left, we, yep. Okay, perfect. Copilot is doing all of these directions correctly, it looks like. Okay, so now we can get the connection positions for a pipe. And then, so this is the one that's a little more complicated, is the start one. So I think what we need to do is... so I need to search all the cells around the start and see which ones have pipes leading back to me. So I think what I want to do is make a function called neighbors. I want to spell it like that for a position. And that's not at all what I want to do. Yeah, okay, so I want to do for y for y in negative y diff. Yeah, let's do that. Y diff in -1 dot dot equals 1. We do this. And then x diff, yep. If they're the same, we continue. Yep. Yeah, so if the either one is less than 0, we continue. Perfect. So we get the diffs. If they're both equal to 0, it's yourself, so we don't have to calculate that one. We try to calculate a new x and y by treating these as signed things. If they're less than 0, we abort. So now we can make them u sizes again. Perfect. If either one of them is too big, we continue. And then it says if the cell's empty, we continue. So that's fair, but I didn't want to do that, but maybe I do. Maybe my function is really just neighbor pipes, because that is all I actually care about. Cool. So that is what we want to do, except I want this, I guess the easiest way to change what we've got is let mutable pipes equal that, and then this is pipes dot push. There we go. And then we finish this whole thing off by just returning pipes. Could have changed these to like maps and stuff instead, but I think this was just a little easier from what I already had. And like we've said, I'm not going for super duper efficiency, and I think this will be okay. I could even tell this to have some capacity so that it knows how much we're probably going to push in and all that, but I think it's okay. Okay, so let pipes equal self.neighbor pipes for position. So then pipes dot iter connection. I want to do something like this. I want to do pipes dot iter dot filter. I want to filter for the pipes, because now I have positions. So this is a position, and where self.connections for position dot includes or contains position, a reference to position. Found. Yeah, let's just leave that alone for the moment. A filter for that one contains this. Yep. But then I can just collect it. That is what I want to do. Okay. A value of vec position can't be built from, okay, so yep, dot cloned. Connections. Oh, I need a, okay, this is the thing that needed the dereferencing. And then position doesn't implement partial equals, but that is just because I haven't told it to yet. Partial equals. Now it will, and so now we can do contains. Awesome. Okay, so if you're on the start cell, you find all the pipes around you. From those pipes, you find their connections, and you filter to one that connects back to the starting point, and you collect that. Yeah, this should be length 2. So then let's start start connections equals this. Assert equal start connections dot length is 2. And then we return start connections. No, I don't want to give you any type hints. Figure it out. Okay, at least all you needed to know is that it was a vec. Okay, so now we can get the connections from any position. So now I think we just need to figure out how to walk the loop. So like a maze needs another function that says like get main loop. And it takes in self, because that's all it should need to work with, and it returns a vec of positions starting at self. So we can do something like, yeah. Wow, it just did a lot of stuff. Okay, let's read this. Let main loop is the vector. Position, we start at start, and direction is down. I don't think that's what I want to do. Let's just write this ourselves. We do want to loop though, so let's okay, perfect. And let's also do let's start equals self.start. Yeah. This is start. I want a new one. Should I just clone it? Is that what it wants me to do? Try start. It just does it. Okay. Oh, because it's copy. It'll just copy it when it feels like copying it. That makes sense. While main loop dot contains start. It's not going to be the most efficient, but I think it'll be okay. While it doesn't contain start, we do something. So we do main loop. Yep, we want to push the position. I'm not trying to read too far ahead because I'm not sure how much of that is going to be right, but we do want to push that. So then we want to say let connections is, yeah, what connections are there out of this? Ooh, okay, we actually do need a direction, I think. Let direction in equals self. Yeah, so we want the connections from start and we want to just get one of them. Yep, so now we have a direction in and we want to find all of the connections. We can't use the same one because now we're looping and we need to get a new one. Yep, okay, so these are the connections for it. So I need, and we know the direction we came in. So I need to like be able to reverse that direction. Because really what I'm saying is, and this isn't a direction, this is a position, isn't it? Yeah. So this is actually previous position. And maybe we actually make this mutable. That's not crazy. So maybe we just have the position and the previous position. And then connections here is a vec of positions. Yep. So then let next connection equals, yeah, like this. So we look at all the connections and we find one that is not equal to the previous position. And then we find the next connection. We do the cloned next unwrap just so we get an actual position value here. So now I think what we want to do is previous position equals position equals next connection. And then we just keep going. And this while loop's not right at all. While, I think I really want to do a do while, so we're going to change this to a loop. And then we say if next connection equals start, we break out of it. And then we have our main loop. Let's see if main loop works for our sample. Maze.main loop, get main loop. Run. I think so. We don't have the count, but 1 1 1 2 1 3 2 3 3 3 3 2 3 1 2 1. Yep. And then we go back to 1 1. Awesome. Okay, so now we need to get the longest, like the farthest away point. So we can just say let our loop equals, oh, we can't use loop. We can call it main loop though. So then let longest distance equals main loop dot length divided by 2. And then this is just longest distance. Because the 1, 2, 3, 4, 5, 6, 7, 8, right? 8, and then divided by 2, you get 4, and that's the right answer. Yep. Sure, we don't need that. Return the expression directly. Okay. Let's see. That actually should now not panic and get all the way through and get our answer of 4, which is easy. So let's plug in our complicated sample. This sketch shows the same loop as above. But let's actually go down to, here's the more complex loop again. Yep. New file, complex sample input. Throw that in there. Let complex sample input 4 and 8 is the answer to this one. 8, yes it is. Awesome. And let's do it with my input. My dot input. So that one just took us a while to parse and get through, but I feel pretty confident in it. Oh, I have to actually use that. Let my input, my part 1 answer. There we go. 6, 7, 25. Nice. Day 10, part 1. Awesome. Let's go to part 2. You quickly reach the furthest point of the loop, but the animal never emerges. Maybe it's within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, the above loop encloses merely 4 tiles. The 2 pairs of blank in the southwest and southeast, marked I below. The middle tiles, marked 0 below, are not in the loop. Here is the same again with those regions marked. So the only ones that are the ones that are contained here, because if you go any direction from them, you hit walls. So they're the only things that are they're the only points that are contained here. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between pipes is also allowed. Here I is still within the loop and 0 is still outside. Yeah, so these ones are outside. Ooh, that one's interesting. Because this is considered inside, and so this is outside. Okay. And then here's a larger example. Shows many random bits of ground, some of which are in the loop and some which are not. And here they're all labeled again. Any tile that isn't part of the main loop can count as being enclosed by the loop. Here's another example with many bits of junk pipe laying around that aren't connected to the main loop at all. Here are just the tiles that are enclosed by the loop, marked with I. In this last example, 10 tiles are enclosed. But I think some of the tiles that are enclosed were pipes. They just are pipes that don't matter. Okay. Figure out whether you have time to search for the nest by calculating the area within the loop. How many tiles are enclosed by the loop? Okay, so let's go back to some simple examples to think through what we're gonna do. How are we gonna calculate enclosed by the loop? So I kind of think that one solution that I can think of, which I'm not sure is the best, is like we can just do a whole scan of the board if we have a method that can calculate if any position is in it. But like looking at this one, oh, I know why it's not enclosed. Okay, I have a thing that I think works. If you go in any direction here, you hit 2 pipes and they negate each other. So like since you hit 2, you're not in the loop, and then not in the loop, not in the loop, not in the loop. But if you ever go and hit an odd number, you are in the loop. So like this one's in the loop because in this direction, or because in 2 directions, it's in the loop. Maybe you need to go in 2 directions. I'm not sure about that yet. But like 1, 2, 3, odd, odd, and then odd this direction and odd this direction. So this one's inside for sure. And this one is not inside, but this is evens on both. So we could definitely do that, right? Calculate how many times you run into the pipe by going out. And does that work for these ones too? I think so. Oh no, it doesn't anymore. Oh, because these were always outside. These one, oh no, odd means inside. I forgot. Odd means inside. Yeah. Which is, yeah, these ones are all odd for the same reason they were before. This didn't change that at all. Yeah, even means you're outside. Odd means you're inside. Yep, that might be it. Um, and I don't think my solution is the most efficient of just scanning the whole thing and asking each position. But the reason I think it's easiest is because I don't really want to do a flood fill that has to deal with figuring out where to start and everything. I feel like it's just going to be easier to do a map scan, and if we can't do a map scan, we'll go from there. Okay, so part 2, well, let's actually just get a function where we can start writing some code. Part 2 takes the same input and returns a usize. So let maze, let main loop. Okay, so now, let count, let mutable count equals 0 for y comma row x comma cell, something like this. Why aren't you formatting for me? Is it just because there isn't? There we go. Perfect. Actually, no, this is just count. We already set up the variable. Let's return it. This is maze. Okay. And I actually don't think I need these at all. I really just want, oh, well, nope, I do need it to do that. I just don't think I actually care about what cell we're in. Okay, so maze dot is inside the main loop, and we give it this position. If it is inside, we count +1. So let's define this now. Okay, so no, I don't think this is what I want either. I want let directions equal that. Yep. Directions dot iter dot map. Count types in direction. So we count pipes in direction from, oh, this is not y. I don't know why I would call that y. That's not helpful. That's position. Main loop. Yep, that's position, and then direction. Got it. Yep. Oops. Count pipes in direction. So, let's just make position mutable. Let mutable count equals 0. Loop. Position based on direction. Do I already have one of these maps? I feel like I do. Yep. This is direction to position. Yep. So let's implement on position, impl position. dot function move in direction. Yeah. So then here I can just do position dot in direction direction. But I do think I need that. Awesome. And then this is up here again. Let position equal position dot in direction. Cool. And what does indirection do about negatives and stuff? It doesn't worry about it, and it's just gonna blow up. Great. That's not going to work out the best for me. So actually this indirection is gonna need to turn an option. Yeah, I know you're gonna be really broken. Connections. Yeah, we know these all exist. Perfect. This one we don't know. Actually, this is gonna be let mutable position equals some position. Oh, while let, yep. Count pipes in direction. Well, that's gotta return not what I told it to return. Count. Okay, there we go. I can't find, oh, this is position like that. Yeah, so let's do that like that, that like that. That doesn't need to be mutable anymore. Expected struct that position. Wait, what? Can I make you P then? And then position equals P dot in direction. There we go. Got it. Is it just that I want to count that? Is that all I want to do? Count plus equals 1. Oh, no. If main loop contains position, count as 1. That's what I'm counting. So now I'm not gonna do the position we start with, but that's perfectly fine. I actually don't think it matters, but that is perfect. So it's inside if they're all this is count mod 2 equals 1. I want them all to be odd. Can I just ask that? I bet I can just ask that. Oh no, maybe not. Not in standard, I guess, which is not unreasonable. Okay, so now I can say if something's inside or not, I think. Oh no, I have to fix this. Okay. Direction is up. Can I do the match? How do I do the match with the ifs? If self dot y is greater than or greater than or equal to 1. Yeah, okay, I think this will work. So then down, if self dot y is less than ooh, I don't know the max here. Yeah. I need to know the max here so that I know when to stop. So maybe this is more like position is a position. I need to put this on map because map's the thing that can know this. So self, all of these selves. Nope, not that. This so substitute at self for position. Okay, there we go. Position at y is less than self dot grid. Oops. Grid dot length -1. It's something like that. I'm not sure if that's exactly right. I need to think about that. Then add the sum there. No, oh, yeah, because this doesn't return that. It returns a position. Perfect. No field y on type maze. Yes. That's supposed to be position. Okay, so if the position.y is less than grid.length -1, yeah, okay, yep. Left if position.x is greater than or equal to 1. We do sum position. And then if position dot x is less than self dot grid at 0 dot length -1, and then it's a sum again. Okay. Self dot indirection. Perfect. A pipe just needs to know it, so which doesn't have a map though. Like, do I want to just say map as a reference to map so that this can be map position direction on wrap? What do you mean you can't find a map? Isn't that what I called this thing? Oh, it's maze. Go to the usage of this, which is up here, which is good because then I can just do self. Oh no, it's passing self this way. Reference to self. Okay, there we go. Is inside. Oh, okay, yeah. You can use an array directly. Perfect. Method is inside. Yeah, neither of these are used because I'm not using them in part 2 yet. Oh, because part 2 is never used. Yeah, okay. Let simple sample part 2 answer. Does that work? Does it do something? It's 5. Simple sample part 2 answer. So simple sample. That should have been 1. 1, 2, 3, 4, 5. Like, why did this get inside? Oh, wait a second. Wait. Did I do this whole thing based on some bad assumptions? Because that would be great. If you're inside, it's even. If you're outside, it's odd. Wait, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. No, these look the same to me. Wait, no, 1, 2, 2. Okay, so if it's an any odd. Is inside is there's any that are odd. Well, now we get 17. Is inside open if main loop contains position, return false. You're not inside if you're on the pipe. Now we're down to 9. But simple, like that's way more than there should be here. It should be 1. 1, 2, 3, 4, 5, 6, 7, 8. So the 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it counted that, I feel like that would be it. But like, which ones are they? Debug position. One, 0. Wait, 1, 0 here? Because 1, 2, 3. Oh yeah, uh-huh. But that's not it. It's if opposing things have odd. If opposing things have odd, no, because these opposing things, oh, have 1. Yeah, opposing directions have 1. Yeah. Or it might be more about, because this is outside, and I want this to be inside. So there's an odd there and an odd there, and there's a odd there, and 1, 2, 3, 4, 5. There's odd all of them. It's all odd. It's not any, it's all. I had this right the first time, and then I think I got bad at counting. Well, let's check some more because I'm also scared. 1, 2, 3, 4, 5, and 1. 1, 1, 2, 3. Yep. What about this one? Yeah, every direction is odd. Yep. Okay, okay. Any direction odd. Any direction odd. 1. Haha. Any direction odd. Love it. Okay. Now let's get rid of the debug that I added just now. Awesome. Okay. Let's do some more samples. Let complex debug it. 0. Complex sample part 2 answer. Uh-oh. Oh, this one actually might not have any inside. That might be the right answer for that one. Okay, so let's do like this one. They give me a lot of samples this time. Inside sample 1 dot input. Let inside sample 1 input. I don't have those. I just have this. I guess I can actually just do that. Let my part 2 answer. Inside sample part 2 answers 4. Okay, so that actually is the right answer, I believe, but it's maybe not very efficient. See if I can run this in release mode, though, and get an answer. Yes, I did. 36. That wasn't too long in release mode. Oh, that's not the right answer. If you're stuck, make sure you're using the full input data. There's also some general tips on the about page. Okay. So here, let's do this final example. Get another example. Final example dot input. Let final sample. I called it final example instead of sample. I don't know. There we go. Final sample. Let final sample part 2 answer. Debug final sample part 2 answer. Yeah. Oops. Nope. No. Reject. Wanted that. So it says 1. Yeah, that's not right. Inside. Yeah, but this one was 4, right? Yeah, this one was 4. This one was also 4. Nope. Oh, but I didn't want it like that. Oh, they didn't give me one that's not like that. Replace dot, replace dot, replace dot, replace dot. Okay. Nope, that one. Replace two, replace two, replace two, replace two, replace two. Yep, so those are both 4. The final one is 1 though. Here the tiles are closed by 8. In this last example, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Here's another example with many bits of junk pipe laying around that aren't connected to the main loop at all. Okay, but it doesn't, so this one's a little annoying because it doesn't show me the main loop. This one at least shows me, I think it's not showing me empty pipes. So 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so I think I think the amount of odd things is either 2 or 4. Let's look at that. So instead of all, let counts num odd equals this, then can be filter for count equals that dot count them. If num odd is 4 equals 4, or num odd equals 2. Eight, was 8 the right one here? 8 tiles are enclosed. Nice. Okay. Now we just see if I can, yes, 1,608. That wasn't too long, a little longer than some of them. Oh no, now my answer's too high. Uh-oh, okay. I thought that might be it. Oh, no, in the last example, 10 tiles are enclosed, and I got 8. Okay, so I didn't get that right anyways. Okay, so let's comment out some of these ones that I don't care about at the moment down here. Just like I'm not worried about this, and these two I'm getting right, so that I can add some debugging to this one and not make it super duper crazy. Debug the X and the Y for all of these. So like I get 8. So I don't know. I can't find one that's missing, but that's okay. 19, 9. So this is the final example. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I think it's this one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one of the ones that I mark here. Okay, well, that's not right. Oh, this one must be one of the junk ones. That's fair. Oh yeah, that's why this one's hard to debug, because it's hard for me to see. And actually, the final one is this one, right? This is the one yeah, okay. So it would be more helpful if I could see the main loop here, and my code can find the main loop. Where's start? Yeah. Wait, is that it for the main loop? That main loop would be really small, so it's not that one, I don't think. Oh, and then we go this way, yeah. Yeah, there we go. Getting it. better. Yeah, but I still don't know how to figure out what this one is. Yeah, so I can't count on this one easy. Okay, so let's do this one. Larger example. Larger dot input, larger sample, I guess. Let larger sample larger. Oh yeah, that's fine. They don't have to match. Ooh, 18. So there's too many of them here. Okay. 19.9 is still one of them though, which is strange. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So it's not as easy as that either. It is probably that they need to be odd in the opposite directions. Okay. Annoying, but that makes sense to me actually. So it's not really just about the directions being odd. It's that I need like opposite directions to both be odd. So this is just the number, but I don't really want the number. This could just be the count. No, I want odd. Oh yeah, so this is odd and then filter. So then this is actually going to give me the direction, right? Oh no, because this is mapping it to count. But that's okay. I can have this map it to D and then the count, direction and the count. Okay, so now I could map this. Actually, really the easier way to do this is just to do this. Found that expected. So I just need one more of those. Nice. Okay, so now we're filtering to the directions that have odd. Okay, so then this can just be collecting to a vec. Okay. Yep, I'm liking this so far. Let odd directions equals this. So then let vertically inside if odd direction contains up and down. Yep. Oh, directions aren't equalable. Partial equal. Nice. Now let's go back to where we were. So vertically inside if up and down are inside. Let horizontally inside if left and right are. So then I think we do vertically inside or horizontally inside. I'm not sure about the and or the or here. Large is 4. That's not right. Did I do an and? Because let's try an or then. Nope, I did an or. Uh-oh. Simple sample part 2 answer is still 1. Oh yeah, that one's the easy one. There is only 1 inside. Okay, so but I only get 14, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0, 1, 2, 3, 4, 5, 6. Yep, so that one like counted. Perfect. 14, 3. So yep, that one also got counted. 5. So these two got counted. But then what about this one? So like 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why is that one inside though? I'm a little concerned that I'm not on the right track here. What if it's just that the up and down have to match? No, because then there's so many in here where the up and down match, right? 1, 2, 1, 2, 1, 2, 1, 2. Yeah, like this matches in all directions, but it's outside, so that's not it. This has 1, 1, 2, 3, 1, 1, 2, 3. Yeah, so this is all odd. All odd, all. Yeah, because it's working. It's probably working for this one. Am I even trying it on that one right now? And actually, let's add some of these where I know the answers. Because I don't think I'm doing myself any justice right now. Part 1, I don't really think it matters as much, but assert equals sample part 1 answer, and I don't know what the right answer for that one was anymore. Let's find out. Oh, it was 4. I know what this, I remember what we were doing here. This is 4. Assert equals an 8. Yep. Assert equals my part 1, and no, my part 1 answer was this. Awesome. Okay. This one. Assert equals simple sample part 1 answer is 1. Inside sample 1. Assert equals, I think it's 4. Inside sample 1. Yeah, this one's 4. Inside sample 2 is also 4. Okay, so it gets it all the way to there. Those ones are all right. A larger sample. Larger example. 8 tiles. Okay, so this is the one that I'm currently struggling with. Assert equals an 8. Yes. Oh no, I got 4. The answer is 8. Yeah, okay. But at least I now know the other ones continue to be correct, because I was a little worried about that. Is inside. Uh-oh, I really thought I could calculate is inside just by counting the pipes I hit in the main loop in any direction, but that doesn't seem to be the case, because these ones are considered inside, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, interesting. 1, 2, 3, 4. 1, 2, 3, 4. So this one just has one of them odd. But I don't think that's right. Odd directions dot length is greater than 0. Yeah, where it's not empty. Simple part 2 answer. Simple. Yeah, so the simple one is broken. So like the one from part 1 that we don't even look at here, this one. Where are the ones where it's odd? Where any of them's odd, actually. And it's not on one of them? Wait, which ones are they? That's actually an interesting question. Like 1, 4. 0, 0, 1, 2, 3, 4. Oh, okay. Yeah. Because it's on the edge. It can't be. if we ignore the edges, though, any odd? Let odd directions that aren't edges equals odd directions filter. Close though. We want to do indirection that is sum. Found. Oh my gosh, I need one more of those. Okay. So because the idea is that to filter out the edges. I think that'll at least get me past this thing, but I'm not positive that's like a good answer. Oh wait, simple sample part 2 answer is still 9. That doesn't make sense. 3, 4. 0, 1, 2, 3. 0, 1, 2, 3, 4. Oh, because I need the opposite direction. Okay, so I need direction dot opposite or something, which I don't have yet. Generate the opposite method. Oop. Match. Yep. Yep. Type direction can't be dereferenced. Yeah, we just don't need any of those now. Okay. Okay, we got a little farther. Inside part 1. But that one, now we got 8 instead of 4. Okay, so that solved this one, but it doesn't solve this one. We get 8. So where's one that we're not supposed to get? 8, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6. Okay, that one we're supposed to get. 7, 6 we're supposed to get. 3, 6. That one we're supposed to get. 4, 6. That one we're supposed to get. Wait a sec. Left 8. Yeah. 8, 6, 7, 6, 3. This one. Oh. 4, 4. Oh, okay. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Oh, yeah. Yeah, this one's got 3 below, 2 above, and then 2 and 2. So this one's, again, where it's the matching, right? If the above and the below match, we're good. But that one, that breaks other things. That's the best I've got, though, right? That gets everything up to larger. And it undercounts. I might have to do some flood filly thing. I don't know how to do that, though. I don't know how to decide what's inside or outside basically at all. Like, there's got to be a flood filly type thing, but I don't even know how to find starting points. Because, like, from a position, I can totally flood fill until we hit walls. That's easy. But how do I find my starting positions to know which ones are inside versus outside? Like, I can even paint these into clusters, but then how do I know which ones are the insides versus which ones are the outsides? Especially in a complicated example like this one. How do I know this one's outside, right? That one looks pretty inside to me. Hmm. Yeah, so like I can go from this L inside, but then how do I know to not go from this L inside? Yeah. That part I don't know how to figure out. It feels like this is more flood filly than counting the number of pipes you cross in a specific direction, just because that doesn't seem to be working out for all of my examples. Yeah, like it breaks on some of these larger ones. Um, like these ones, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Oh yes, that's the any. But any just doesn't work at all. That's too many things. And then I tried any that aren't that aren't on the edge, and that wasn't right either. Well, could I like flood fill from these ones? I could, but that doesn't feel like very satisfying, because why am I like I'm not sure I'm finding all of the groups with this logic. Like I definitely don't think I would necessarily be. Odd directions that aren't edges, yeah. Oh, nope, that doesn't work. I was gonna say that maybe I wanted to flood fill from the outside first. And that works on some of these simple examples, but it wouldn't work here, right? I wouldn't be able to say that this is outside then. Oh, yes, I can. Flood fill from the outside, and every time you touch a pipe, you switch. Every time you cross a pipe, you switch. So like here, we crossed a pipe, didn't cross a pipe, didn't cross a pipe. Yeah. Yeah, what if I need to count every time I hit a corner, not any time I hit a wall? Corners from here are 1, 2, 0, 0, 0. Nope, it's not about hitting corners necessarily, but if I flood fill through them, I think that will work. Every time I don't follow the direction of a pipe, it counts as switching. Yep. Yeah, let's do that. Okay, so let's do Rust ignore dead code because I want to this one at the crate level. Because I want to just leave all my code and I don't want it yelling at me about code not being used. Okay, so part 2, we're doing it differently. We need our maze and we need our main loop. Let count equal. Is that what I want to do? No, let mutable visited equal a vec of this. Let current position is, nope, actually current position is just going to be 0, 0. Yep. Let mutable to visit equals current position. Actually, so I don't want that. This can just be 0, 0. Inline it. No, nope. Ah. Okay. While let some pop to visit. There we go. Um, if visited contains position, we continue. So then we make it visited. We look at from the maze. So that gets us neighbors, but I don't want that. So let neighbors was maze dot neighbor. So this is neighbor pipes. I don't want neighbor pipes anymore. I want neighbors. So neighbors. We don't check if it's empty. Self dot neighbors filter for a pipe collect. There we go. Yeah. Cool. Just so I don't have to have that logic multiple times. So this is neighbors, and actually this is where I already have this logic. So I think I can just do I think I can just do less of this. Oh no, because I don't have the this isn't using directions, just because that's not how this is working, and it doesn't make sense to. Oh, I have neighbors here going in all four corners. I don't know if I want that. What is neighbor pipes used for? Uh, Connections. You look at your neighbor pipes. Yeah, it doesn't need to do all those. It really just needs to look at directions. Let directions. Yeah. Um, Directions dot iter into iter dot filter. It's just a filter map. Wow. Neighbors, you just go in the direction. For all the directions, you go in all the directions. Love it. Neighbor pipes, we just filter those for where it's a pipe. That's perfect. Okay, awesome. So now let's go back to, well, actually, let's see. Cargo run. Is this, yeah, this is this thing. That's fine to do. I want to make sure that my old answers are still right and everything. 6, 7, 25. Yeah, that's right. Perfect. And we just ran into my to-do. Okay, awesome. Okay, so to visit, I think actually to visit might need a struct. A position, no, and then it's inside, which is a Boolean. We need to know whether we're inside or outside so that when we cross a pipe, we know to flip that. Something like that. And then this then becomes a to visit of position, and inside is false. To let position equals 2 dot position. Okay. So we want it, we know we need to go to this position. If we visited it, we just continue. Now we visited it. We look at all of the neighbors. And then we say neighbors.iter. So we find, no, we don't want to do that. We just want to take neighbors and map over them. Yes, let's just do this. But that's like not the right type. Yep. Neighbors dot into iter map to visit. Yeah. And then this isn't right though, because we don't want inside. So then I want to say neighbors. Does neighbors doesn't return the direction with it. I would like it to return the direction with it. Direction, comma, position. Direction, comma, position. Oh yeah. I want direction dot map that. Filter for underscore dot map position. There we go. Okay, cool. So now neighbors returns what I want it to return down here. Because neighbors is now a direction and a position, so that I have direction and position. Position we use, and so direction is the direction it took to get us to that neighbor. So now if I'm at that neighbor and I have a direction, awesome. I was hoping it wasn't going to change that for me. So let opposite. Let's get the opposite direction. Let old equals maze dot in direction opposite. We know we're gonna get there because we came from it. I don't know if I really need to do it this way, but we're doing it at the moment. I want to say if let cell equals maze, yep. If cell if we matches a cell but not empty, cell and pipe. Oh wait, no, I actually don't really care about it being any pipe. I want it to be if position, if our new position that we're exploring. Oh hey Opus, how's it going? Sorry I missed your message a few minutes ago. I am pretty deep in this Advent of Code puzzle. We're doing day 10. It's very mappy. I'm trying to implement a flood fill at the moment, where I have to like determine whether it's inside or outside of these series of pipes. So yeah, glad you're doing all right. So I think I have it figured out where we're flood filling from the outside, and every time we pass a pipe, and every time we cross a pipe, we switch whether we are inside or outside. So like when we cross a pipe, we switch. So like we would be inside, but there's not actually a thing here, and then we cross it again, so we're back outside. But if you follow a pipe, right? So like just going down the direction of a pipe, that doesn't flip it. So yeah, it's great. It's great. Let mutable inside equals 2.inside. Yep. If main loop contains, I actually don't really know if I care about old at all. Opus said, finally figured out the solution to a problem I've been tackling at work for the past month or so. Well, 80% of the solution, still some work needs to be done, but the big blocker is gone. That's awesome. It feels really good when you kind of can all of a sudden find a blocker that you weren't sure why it was before. So we have a pipe, and we know this is a pipe. If let pipe equals find. Is that, can I do that? Dot index. I can do index, but I don't want index. Okay. Let some type index. What? Oh, do I need a... The type can't be indexed by this. The trait. Oh yeah, I don't want that. I want find. Find is the one I wanted, I think. Iter.find. Iter.index? Is that what I'm looking for? Okay. Rust index of. Position. I might have to pass position a closure. Okay. No, and I don't want ult. I think I need to get rid of it so it stops trying to use it for things. So I'm trying to find the type equals main loop. There we go. Okay. If type dot connections, if pipe connections contains, when do I flip it? I flip it if it contains one of the directions but not the opposite, or not the other, right? So pipe dot connections, pipe is a position. Oh yeah. Okay. Let pipe, so this is a position. Pipe position. Oh man. This is getting complicated, but that's okay. Let pipe equals maze. Yep, there we go. Yeah, that's fair. There we go. Because I know it's a pipe. If pipe.connection contains opposite, exclusive, or pipe.connections contains direction. It can contain, if it contains one but not the other, we flip it. Phew, okay, let's read this. So we're flood filling from the outside. We start with having a thing that's to visit at 0, 0. If we've visited it, we continue. We find the neighbors of it. We map over those neighbors and we get the direction and its opposite. So the direction we came into this and then the opposite, just to get both of them. And then we're gonna maybe change whether we're inside or not. If we run into a main loop pipe, we know it's gonna be a pipe. If that pipe has directions in and out, like if it's just a straight through that we just did, we don't flip it. But if it contained one and not the other, we do flip. And then we're to visit inside. And then we add neighbors to visit. Yep. And then that is all. And then the answer here is visited dot filter. What's visited? Oh, visited is just the positions, right? Yeah. Let count. Oh no, I actually think I want visited to be something different. It's really just this whole thing. Like I want it to have the to visit thing too. Visited is a vec of to visit. My naming's a little bad now, but I think this flood fill will make sense. If visited contains, oh yeah, visited. Oh yeah, that's fair. Yep, I kind of do want visited just to be this. Okay, so then let mutable inside. That's fine. We can have both of these. Vec bang. Type annotations needed. Yeah, that's fine. You'll figure it out in a second. If it's inside, we push inside. There we go. And then this at the end is just inside dot length. Okay. Okay. Run. Blow up. Not a pipe. Cool. Not a pipe. Okay. Main loop iter position equals position. Oh, yeah. This is a little complicated. Like, I think I can make this simpler, and I don't think I'm going to make the bug go away, but that's okay. Main loop dot contains, it thinks I want that. If main loop contains position, position, wait, what is it? Is it, so P is gonna be my new one, is the neighbor. Yep. Okay. That's simpler. Is it more right? Still get not a pipe right away. Line 300, which is right here. Perfect. Main loop contains P, and then you get the thing that's at that. That should be a pipe. That's a little concerning. Why is it not 1 1? And this is probably like sample, like the, yeah, simple one. So like the input file that I'm looking at to this one in 1 1 0 1 0. So I'm looking at the start position. Oh, I'm looking at the start position. That's fair. I might not have thought about the start position super well in this implementation. That's pretty fair actually. Um oh yeah, because it could be the start. I bet it's the start. It's definitely the start. Yep, okay. Let connections. I will actually want to change. First of all, let's change this if let to a match. Perfect. Cell start. Nope, cell start goes to a to-do block. And so what if I just make this connections? This is then just pipe dot connections. So then that can just be connections, and that can just be connections. And then this can be maze dot start connections. Isn't that a thing? Didn't I write a start connections method at the very beginning here? Connections. Oh, I wrote a connections method that does this. So it's just maze dot connections, and yep, pass in P. But I actually really can just do. No, I'll leave it like that. Connections. What does this return though? A vec of positions, a vec of directions. Yeah, fair. Yeah, so I have positions, not directions, and I kind of want directions. So this gives me positions and I want directions. Dang it. I could write the impl of those, the reverse of that, but I don't really like that answer. It's really easy though. Um, yeah. Connections. Yeah, this calls connection positions from that. Yeah. Mm-hmm. Connection directions. No, that's hard to do as well. I can make it just something that I need to implement for start if I do it down here. And I bet Copilot can write me the direction from positions code without too much effort. Function direction. So the direction to, yep. Perfect. Panic. Oh, else those, wait. Oh, it's telling me to collapse it. Got it. Not really sure I love this thing, but that's okay. It's just gonna return the wrong thing a lot instead of panicking or anything. If self.x equals other.x and self.y plus 1 equals other dot y, we return down. So if I am one more than direction 2, so down. Yep. Okay. Yep. If, come on, Copilot, you got the rest of these. Panic. Not adjacent. Perfect. Okay. Connections dot into iterator dot map a new position. So then I want p dot direction to new. Okay. Whew. Okay. Well, I got an answer, but it's not the right answer. Let's see if we can look at some of these and maybe it'll be obvious. But we might wrap up here soon because I've been working on this for a little longer than I expected to. Debug out the inside ones. No, no, no. So like 3, 1. 3, 1. I wonder why 3, 1 thinks it's inside. 0, 1, 2, 3, 0, 1. So it's this one. Wonder why that thinks it's inside. Because we were outside and then we became inside. Oh, do I have to like if inside and not main loop contains position? Shucks. Thought that one was gonna do it. Just filtering out ones that were on the loop. So now we get 0 instead of 1. So now we're not counting the inside one correctly here. Because like we would go from here, here to here, then we'd be inside, kind of. We'd have it marked inside. We'd go here, that just follows it. And then we'd go here. Oh, because we didn't do it when we leave one, I bet. Okay. Because we're saying if the thing you're going to. Yep, so if the thing you're going to. Wait a sec, I'm a little lost. Okay, so this is the things that to visit. So this is our current one, though. And then we go to its neighbors. So if going from the one we were at, which is position, to P. So P, if P is, oh yeah, but what if the old one, what if let connections equals, match maze.grid of position xy. What? Oh, reference to. Oh, because that's not supposed to be pipe. That's supposed to be this thing. Pipe.clone. Actually, connections.clone will work too. Might as well do that at the end here. Okay. Let's see how much we can get in 13 minutes. Once we hit the 2-hour mark, I'm going to call it a day. So we have to count the leaving ones as well. And if you leave, like you do both of them, that's fine. It's just going to work. Dang it, not a pipe. Oh yeah, but that's fine. We might not be getting to a pipe. If main loop contains position, there we go. If we were leaving, okay. Entering a pipe, exiting a pipe, exiting a pipe. Empty cell has no connections. Yeah, but where do I think we call that? Where do we, okay, so, but here I think it's a star. Oh, this needs to be position. Not adjacent. Okay, that's a more interesting one. That one's an interesting one. How do we think that happened? Oh. I didn't freaking, this is why like we make methods and stuff. Aw, dang it. Okay, we got nothing inside. So this doesn't seem like it's gonna work. Let's look at this really quick to make sure there's not another silly mistake here. I don't see one. Yeah, because this is when we make it mutable. Yep. We maybe flip it. We maybe flip it again. Wait a sec. If we're exiting a pipe. Since we do the opposite, I guess it doesn't really matter which direction we go. That's fair, because I want to say that it's both of them. Yep. Okay. So that's not it. It's just when they make the right angles that I want to count them. Yeah, because I'm going straight. So yeah. Yeah. That looks right to me. I'm not finding a bug, and we're getting a not adjacent error. Oh no, we're not getting that anymore. We just aren't getting the right thing. Okay. I think we're probably gonna call it then, because I'm not seeing it. I'm not seeing a bug, and I don't really want to just keep debugging this live, and it's been a while. So I think we're gonna call this at 2 hours probably. And we will probably try again tomorrow, maybe later today, but no, we're gonna call it tomorrow. I think I'll probably be done for the day here. Oh, I just don't want to yet. I want to figure out what's going on, but I don't think I'm gonna. Position dot direction to new. Yep. I think the thought makes sense though, right? Because if you're going from like, you go from here, now you're inside, you leave it. Now you'd be out. No, 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 no. I don't want exiting, and I don't want that, because then like going down here, it's outside, inside, outside, in. Yeah, that's not right. That's not right. Okay. You don't do exiting a pipe. That doesn't make sense. This is wrong. We don't want to count exits as well as entrances. Yeah, we don't want to count both. Because if we count both, then we'll like go outside, inside, outside, inside, outside. Like it just doesn't, it won't work quite as right. We want to go inside, inside, outside. Like that. Yeah. And then this should say inside. But obviously it's not, and I don't know. Yeah, I don't know where we get to. Like why we get the if P equals position at 0, 0, but it's not 0, 0 that I want. I want, well, 3, 3, 3, 0, 1, 2, 0, 1, 2, 2, 2. When position is 2, 2, expected semicolon. What? Can surround the struct literal with parentheses. What? Wow, that is what I wanted. Okay. Like that's not really gonna help me though. The answer is just gonna be false. No, it's not. It's, oh yeah, it is. True, false, false, true. Also, why did I get here so many times? And why is it sometimes inside and sometimes outside? Shouldn't I have only got here one time? Oh. What if I... Oh, it visited. Yeah. Hmm. But what if we do that after we maybe push it? What if we push to inside first? Now we get a lot more that are inside though. That's interesting. If inside and not in the loop. And what's interesting is they're not duplicates. I thought we were going to get lots of duplicates, but we don't get duplicates. We get like 4, 1. 0, 1, 2, 3, 4, 0, 1. Yeah, that one really shouldn't be inside. Wonder how we got to this one. Like when you hop from here to here, yeah, that was supposed to flip it. So then hopping to here shouldn't. Yep, okay. I think I'm gonna get out of here for the day, team. I need a break from this one. But this one's a fun one, but it's a little bit of a struggle. These map ones can get tricky. And I think my flood fill idea is the better idea I've had, but I just am struggling with the implementation. So I'm gonna call it a day, I think. Thanks for coming and hanging out with me, everyone. Sorry we didn't get this solved, but we will be back trying day 10 again soon. And in the meantime, have a good weekend, everybody, and I'll see everyone online. Thanks, team. Bye.